Hello everyone. In the last lecture, we have briefly discussed about the different types of timers. In this lecture, I will show you a couple of application programs on the timers and we will be trying to solve them. Okay. Now, let us look at the two problems that I have taken, two small programs. Okay. The first program is turning a LED on and off for every 2.6 seconds. Okay, first we will try to solve this first program and then we will come back to the second program. Okay, now let us clearly read the program number 1 once again. Write a ladder logic program to turn on and off an LED for every 2.6 seconds until the switch is turned off. So if you consider this program, basically you have a switch which is having on and off. These are the two switches that are present. Now our task is when we switch on the when we press the on switch, the LED should start to blink. For every 2 seconds it will be turning on and off, and when this off button is pressed, this whole loop will stop. Okay, I hope you have understood the basic concept. Now we should come into the programming. Okay, for this programming I have taken the TIA portal software. There are multiple logics through which you can implement this program, but I am taking one logic. Your logic that you might think might be different from the one that I am using. Okay, so first I am taking two inputs. Okay, these are the two inputs. One is the on switch and the one is the off switch. Then I have taken a timer and then I have connected the output. Then I am taking another loop where this output is connected as the input for triggering the off one, and then I am giving this output again as the input over here for the loop to continue. Okay, I am assigning addresses over here. I am addressing this as the on switch. This one as the off. Okay, I am taking this as the on timer. Our task is 2.6 seconds on and off. The units of the preset time over here are milliseconds. So when you give 2600 as the input, you will be getting 2 seconds 600 milliseconds, which otherwise is nothing but our 2.6 milliseconds. Here I am taking a memory address again over here, M2.0. This output is used to trigger this one. Here also I am taking a on timer. This output that we are taking over here is a temporary output. It is a temporary output, and this one is the LED that we are going to use. Okay. The logic is simple. I will try to explain you the logic. When the start button is pressed, the off button will be in the off mode. So the input will be high over here. the input will be high over here. Okay, this output will be low, so this will trigger the on. So initially the system will be, the input will be high. After 2.6 seconds the LED will become on. When this LED will become on, this loop continues and the cycle will continue. Okay. And the cycle will continue. Okay. Now I will execute this program and I will show you. Okay, now I am running it in simulation mode. Okay, now I am turning on the on button. When I am turning on the on button, initially the LED is on. After 2.6 seconds the LED will be turned on. Then this temporary one will be triggered on and the loops rotates and the loop continues. Okay, here in this example I have taken two on timers. The same logic can be implemented by using one on timer, one off timer, or two off timers, or with the help of a retentive timer also. Okay, this is one simple example that we have taken. Okay, I hope you have understood this example. Now let us consider the second example. Okay, if you can look at the second example, it is said that there are three mixing devices A, B, C. Okay, when the process is started, the mixer A will start after 7 seconds. The mixer B will start after 3.6 seconds after A, and the mixer C will start 5 seconds after B. And when it is turned off, the whole loop will be turned off automatically. Okay, for implementing this we will be using our on timers. By using the on timers we can implement this system. Okay, let us remember the times: 7 seconds, 3.6 seconds and 5 seconds. Okay, this is our second program. Okay, we have a start switch, we have a stop switch, and there are three timers that we are going to use. Okay, I am giving addresses. I am giving M1.0 as the uh, program to on switch. This is my switch on. This is my switch off. Okay. For implementing this program, we will be using the on timers. Okay. Now, if you look at the program, the first mixer should start after 7 seconds. So for 7 seconds, the value that we need to give it in preset time is 7000. Here you can see the 7 seconds. Next one is 3.6 seconds. So for 3.6 seconds, you need to give 3600. And the last one is 5 seconds. So here you need to give the preset time as 5000 seconds. Now, what is also given? The process A will start first. So I am giving the address over here 1.2 M1.2. This is my process A. This is my process A. In the question, it is said that of the B will start 3.6 seconds after A. So the A address should be given over here. A address should be given over here. I am giving address to the B. This is my B, process B. And the process C will start after the B process is completed. So I am assigning address over here M1.4. This is my process C. I have saved the program. Now I will show you how to execute this program. As we have already implemented the above logic in simulation, we need not do the simulation part again. We need to just download to device software only changes. As we have done only changes to the existing ladder logic. Load. Okay, now go to the monitoring button. So I have turned on the, okay. Okay. Now I have turned on the switch. When I have turned on the switch, after 7 seconds, the process A will start. After the process A has started till 5 seconds, it will 3.6 seconds, the process B will stop at, and after 5 seconds, the process C will stop. Okay. Now, when I make the switch on switch high, the whole process will stop automatically. Okay. So that is how we have implemented this logic. Okay. I hope you have understood. With this, we have concluded the second example. Okay. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.